I'm going to present some cognitive perspectives on the application of problem structuring methods in group model building with system dynamics. I'll start my presentation with the story of the guaranteed cockroach killer, as written by Goss and Weinberg in their book Exploring Requirements 1989. So it was a man in New York City who actually made a living through selling a guaranteed cockroach killer in the classifieds. If you paid the money, you would actually receive a kit that included 2 blocks and a set of instructions. Instructions were like this: place cockroach on block A, and then hit cockroach with block B. Simple as that. So basically, this is the guaranteed way you can kill the cockroach. This can simply remind me of the guaranteed OR problem-solving methods, which actually tell us formulate the problem, construct a mathematical model, solve the model, test the model and the solution, then put the solution to work. Simple as that. But we're living in a world in which we face very difficult problems that are not like the traveling salesman problem that can be simply modeled and solved. If we cluster the problems based on their degree of randomness and the complexity, we come up with 3 different categories of problems. If we give the example of, for example, if you want to analyze the motions of a billiard ball on a billiard table, if we want to do it for one ivory ball, then this simply can be done by the application of the conventional mathematical tools that can deal with problems of limited components and wherein there are actually predictable relationship between these components. If we increase the number of the balls to 2 or 3, the complexity of the problem rises with a very huge increase in actually mathematical calculations, so that it becomes actually impossible if you want to do it for 4, 5, or 6, or 10 balls. Surprisingly, if we have to, for example, analyze the same type of movement for 1,000 or millions of ivory balls on a billiard table, we are facing a problem which is simpler, because we can apply the methods of statistical mechanics that can deal with huge number of components that are related to each other in unpredictable ways. But the problems we are facing in real life and in organizations are a problem of organized complexity. A lot of operations research scientists, especially those who are active in the field of soft OR, have came up with different names that can be used actually to describe this type of problems, the problems of organized complexity. Acuff calls them messes, Riddle calls them wicked problems, and Sean gives them the term swamps. These problems have all some characteristics. They share some characteristics. Most of the conventional OR methods actually assume that stakeholders of a problem are passive objects within whom a consensus exists. So it's basically possible to assume a unitary perspective about what their assumptions and what their needs and wants are, which is not correct. We have problems with multiple stakeholders, and each of these stakeholders hold different perspectives. And sometimes, due to the different value and belief system that these stakeholders have, we face conflicting interests. And there are, of course, a lot of key uncertainties about what basically they want and what their needs are. Therefore, we need a different methods for the inquiry. We need methods in which the reasoning is basically informal and more intuitive, rather than methods in which we apply logic-mathematical reasoning. We are dealing with evidence which is basically more intuitive and based on perception of facts, rather highly confirmed observations. The generalizations used in such methods of inquiry are quasi-laws. They're not established laws. Models are mostly heuristic-based, rather than being solid foundations for predictions. Explanations are perceived causal relationships, rather than tested hypotheses. And the predictions are intuitive, based on some considerations. So these are the reasons for which we need some new modes of inquiry. And that's the interesting part to see that, well, basically we can see this happening in real life. We're actually conducting research about Amazon.com and the various aspects of its business model, and we came up with something very interesting in 2005 annual report by Amazon.com. Most of the annual reports of Amazon.com have their own conventional annexes and attachments, like the letter to the shareholders and let's say the financial indices and so on and so forth. But the annual report 2005 has a very interesting attachment. That attachment is the paper by Mintzberg. It's the structural and unstructured decision processes. And why is that paper attached to this annual report? The reason is, Jeff Bezos explains. So before coming to this paragraph, he explains how they can apply the mathematical models and tools in order to understand things about the optimum inventory turnover and things like that. And then he continues and says that basically not all their important decisions can be made in this mathematical way, because there are sometimes no historical data, and it's not possible to do some experimentation. And what they need to do is make decisions based on judgment and intuition. So we see even big companies like Amazon are, after many years of being in the business and knowing the business context and the environment, have to sometimes rely on their judgment and intuition rather than focusing on some guaranteed problem-solving methods.